Hi everyone, Chapter 4, the variation in logistic regression. So we discussed several small topics related to the binomial and binary regression models. Okay, so first the 4.1, the latent variables. So this section gives another interpretation for logistic regression model. So does not discuss the new models. So exams for students. So here the data is the sample unit. Here the sample unit is a student, and suppose that the D is the difficulty of the exam. So this is a predictor. So usually we use X for logistic regression, but here we use D. And a random variable, a randomly selected student's aptitude is T. So this is random. So because the randomly selected student's aptitude depends on the student, so it's random. And the student makes a wrong answer if and only if T is less than or equal to T. So here the T is random, but the outcome is not random given T. So the usual linear regression involves some error term, but here each student have some randomness, and then the observation has some randomness, but after that the T is less than or equal to D. Always that student makes a wrong answer to that question. Okay, so now that we assume some assumptions on T. So let P be the function f of D, and this is the probability of T is less than or equal to D. So probability, so this is basically the probability to make a wrong answer. And we define this as exponential of the D minus mu over sigma over the 1 plus exponential of D minus mu over sigma. So this is actually the logit function. So inverse logit function. So inverse logit of D minus mu over sigma. So if we rewrite this relationship, we multiply the logit function, then logit of P is the D minus mu over sigma. So in this setting, basically, okay, so logit of P is just the quantity represented by a linear combination of predictors in logistic regression. So actually, this is exactly the same as logistic regression. So D is X. So negative mu over sigma, this quantity is beta naught, and 1 over sigma, that is beta 1. So this is a logistic regression model. So in this sense, that we can see logistic regression as some model for the random variable. So we haven't specified the random variable before, but now that we see the random variable is in T. Yeah, so this means that T has the inverse logit function as the cumulative distribution function. So remember that the inverse logit function is a function which ranges from 0 to 1, and the domain is negative infinity to positive infinity. So this is y is equal to I logit of x. So you can see that T has the cumulative distribution function as the inverse logit function as the cumulative distribution function, CDF. So this, the latent variable interpretation is also used for the bioassay. Here, the sample unit is an animal, and D is the toxic level, and the outcome is whether the animal dies, and the T is tolerance. So in this case, okay, so the tolerance depends on an animal, so this is random. But once we have chosen an animal, if the tolerance of that animal is less than D, then the animal dies, and otherwise it survives. So this is the same situation as the previous example.